There is already a small set of primitive types available in JavaScript: Boolean, BigInt, null, number, string, symbol, and undefined, which you can use in an interface. Typescript extends this list with a few more, such as any, allow anything, unknown, ensure someone using this type declares what the type is, never, it's not possible that this type could happen, and void, a function which returns undefined or has no return value. You'll see that there are two syntaxes for building types: interfaces and types. You should prefer interface. Use type when you need specific features. Composing types. With TypeScript, you can create complex types by combining simple ones. There are two popular ways to do so: unions and generics. Unions. With a union, you can declare that a type could be one of many types. For example, you can describe a Boolean type as being either true or false. Type myBool equals true, false. Generics. Generics provide variables to types. A common example is an array. An array without generics could contain anything. An array with generics can describe the values that the array contains. Structural type system. One of TypeScript's core principles is that type checking focuses on the shape that values have. This is sometimes called duck typing or structural typing. In a structural type system, if two objects have the same shape, they are considered to be of the same type. Of course, here's a technical audiobook-style text on TypeScript, using bullets and numbering properly, making it easy for audio listening. Underscore. TypeScript is a superset of JavaScript that brings strong typing and modern development features to web applications. It was developed by Microsoft to address the growing complexity of JavaScript applications, providing better tooling, earlier error detection, and more scalable codebases. In this chapter, we will cover the key features and benefits of TypeScript, step by step. Static typing. TypeScript introduces static typing to JavaScript. Developers can declare variable types, function parameter types, and return types. This allows the compiler to catch type mismatches before the code even runs. For example, if a function expects a number but receives a string, TypeScript will generate a compilation error. Static typing improves code safety, makes applications more predictable, and helps prevent common runtime bugs. 2. Interfaces. Interfaces in TypeScript are used to define contracts for objects. They describe the exact shape an object must have, specifying which properties are required and their types. Interfaces make it easier to create consistent, well-structured code, especially in large applications. If an object fails to match the interface structure, TypeScript immediately flags the issue. 3. Classes and object-oriented programming. TypeScript enhances object-oriented programming in JavaScript by supporting classes, inheritance, and access modifiers. Developers can define classes with fields, constructors, and methods. They can extend classes to create new ones and implement multiple interfaces. Access modifiers such as public, private, and protected control the visibility of class members, allowing better encapsulation and data hiding. Generics. Generics allow developers to create reusable components and functions that work with a variety of data types without losing type safety. Instead of specifying concrete types, generics act as placeholders that are replaced with real types when the code is used. This leads to highly flexible and type-safe code, reducing duplication and improving code maintainability. 5. Enums. Enums, or enumerations, provide a way to define a set of named constants. They make code more readable and easier to maintain by replacing numeric or string literals with meaningful names. For example, instead of remembering that one represents a success status, developers can use an enum like status.success.6. Advanced type features. TypeScript offers powerful advanced type features, including union types, intersection types, type aliases, map types, and conditional types. These advanced types allow developers to express complex data structures and relationships with precision. They also enable building highly flexible APIs that remain type-safe without sacrificing expressiveness. 7. Tooling and editor support. One of TypeScript's biggest advantages is its deep integration with modern editors like Visual Studio Code. Developers benefit from features like intelligent autocompletion, real-time error checking, refactoring tools, and navigation support. This greatly improves productivity and code quality by providing immediate feedback during development. 8. Compilation to JavaScript. TypeScript code is transpiled into plain JavaScript using the TypeScript compiler, known as TSC. The compiler can target different JavaScript versions such as ES5 or ES6, ensuring compatibility with various browsers and environments. The output JavaScript code is clean, readable, and ready to run anywhere JavaScript runs. 9. Ecosystem and adoption. TypeScript has gained massive popularity and adoption across the web development ecosystem. Frameworks like Angular use TypeScript as their primary language. Many libraries offer TypeScript type definitions, and entire development stacks are now TypeScript first. This trend reinforces TypeScript's role as a standard for building modern, scalable web applications. In conclusion, TypeScript brings the discipline and power of statically typed languages to the flexibility of JavaScript. By introducing types, interfaces, classes, generics, and advanced tooling, it enables developers to write safer, cleaner, and more maintainable code. Mastering TypeScript is a fundamental skill for building robust, scalable, and future-proof applications in the modern web landscape. Here's a technical audiobook-style text for utility types and decorators in TypeScript, using bullets and numbering, and keeping it natural for listening. In this section, we will explore two advanced but powerful features of TypeScript. Utility types. Utility types in TypeScript are built-in types that transform or operate on existing types. They allow developers to manipulate type structures without rewriting them manually, saving time and reducing duplication. Here are some of the most important utility types. Partial creates a new type where all properties are optional. It is useful when updating only parts of an object. Required converts all optional properties into required ones, ensuring that every property must be supplied. Read-only makes all properties of a type read-only, preventing reassignment after the object is created. Pick type keys constructs a new type by picking a subset of properties from an existing type. Omit type keys creates a type by omitting specific properties from an existing type. Record keys type constructs a type with a set of properties defined by keys, all having the same type. Exclude type excluded union constructs a type by removing types from a union. Extract type union constructs a type by extracting types from a union that are assignable to another type. These utility types provide dynamic, flexible ways to modify type behavior, making TypeScript more expressive and reducing code repetition. Decorators. Decorators are a special TypeScript feature that allows developers to attach additional behavior or metadata to classes, methods, properties, or parameters at design time. Decorators are declared using the @ symbol followed by a function name. They are heavily used in frameworks like Angular to inject services, configure routing, and modify class behaviors dynamically. There are different kinds of decorators in TypeScript. Class decorators. Applied to classes, they can modify or replace a class definition. For example, marking a class as a service or component in Angular uses a class decorator. Method decorators. Applied to methods, they can alter the behavior of the method, such as logging calls or applying access control. Property decorators. Applied to properties inside a class, they can modify how a property is accessed or stored. Parameter decorators. Applied to function parameters, they can be used to inject metadata or dependencies into constructors. To enable decorators in TypeScript, developers must configure the experimental decorators option to true in the sconfig.json file. This is because decorators are still an experimental feature in the ECMA script specification. Under the hood, a decorator is simply a function that takes different arguments depending on where it is applied, such as the class constructor, property key, or method descriptor. Decorators allow powerful metaprogramming capabilities, giving developers fine-grained control over object behavior at runtime conclusion. Utility types and decorators are two advanced but essential features of TypeScript. Utility types enable powerful manipulation of type structures, keeping code dry and maintainable. Decorators, on the other hand, allow metadata-driven design and dynamic behavior enhancement, especially in frameworks like Angular. Together, they help developers build sophisticated, scalable, and flexible applications with less effort and higher reliability. Some of the unique concepts in TypeScript describe the shape of JavaScript objects at the type level. One example that is especially unique to TypeScript is the concept of declaration merging. Understanding this concept will give you an advantage when working with existing JavaScript. It also opens the door to more advanced abstraction concepts. For the purposes of this article, declaration merging means that the compiler merges two separate declarations declared with the same name into a single definition. This merged definition has the features of both of the original declarations. Any number of declarations can be merged. It's not limited to just two declarations. Basic concepts. In TypeScript, a declaration creates entities in at least one of three groups: namespace, type, or value. Namespace creating declarations create a namespace, which contains names that are accessed using a dotted notation. Type creating declarations do just that. They create a type that is visible with the declared shape and bound to the given name. Lastly, value creating declarations create values that are visible in the output JavaScript. Merging interfaces. The simplest, and perhaps most common type of declaration merging is interface merging. At the most basic level, the merge mechanically joins the members of both declarations into a single interface with the same name. Using modules. Modules can contain both code and declarations. Modules also have a dependency on a module loader, such as common.js/require.js, or a runtime which supports S modules. Modules provide for better code reuse, stronger isolation, and better tooling support for bundling. It is also worth noting that, for Node.js applications, modules are the default, and we recommended modules over namespaces in modern code. Starting with Typescript 2015, modules are native part of the language, and should be supported by all compliant engine implementations. Thus, for new projects, modules would be the recommended code organization mechanism. Using namespaces. Namespaces are a TypeScript-specific way to organize code. Namespaces are simply named JavaScript objects in the global namespace. This makes namespaces a very simple construct to use. Unlike modules, they can span multiple files, and can be concatenated using outFile. Namespaces can be a good way to structure your code in a web application, with all dependencies included as script tags in your HTML page. Just like all global namespace pollution, it can be hard to identify component dependencies, especially in a large application. /directives. /directives are single-line comments containing a single XML tag. The contents of the comment are used as compiler directives. /directives are only valid at the top of their containing file. A /directive can only be preceded by single or multi-line comments, including other /directives. If they are encountered following a statement or a declaration, they are treated as regular single-line comments, and hold no special meaning. As of Typescript 5.5, the compiler does not generate reference directives, and does not emit handwritten /directives to output files unless those directives are marked as preserve equals true. The /reference path equals greater than directive is the most common of this group. It serves as a declaration of dependency between files. /references instruct the compiler to include additional files in the compilation process. They also serve as a method to order the output when using out or outFile. Files are emitted to the output file location in the same order as the input after pre-processing pass.